Hey guys, how are you doing? In today's video we will talk about the relation between the derivative and the monotonicity of a function. So grab your pen and paper and I will see you in a minute. First, let's look at an example. Let's consider the function x squared minus 1. One can immediately see that it is decreasing for negative x, and it is increasing for positive x. But now we can zoom on the derivative, and we can see that the derivative is negative when the function is decreasing, and the derivative is positive when the function is increasing instead. From this example, we can deduce the general rule, which is that if f prime of x is positive on an interval ab, then f of x is increasing in that interval, and if f prime of x is less than or equal than 0 in ab, then f of x is decreasing in that interval. And now let's move on to some exercise. As a first exercise for today's videos, we are gonna identify the interval where the function f of x, which is equal to x to the power 3 minus x, is increasing or decreasing. So, following a general rule, what we have to do? We have to identify the interval where the function f prime of x is bigger than or equal than 0, and in this case the function f of x will be increasing, and whenever instead the function f prime of x is less than or equal than 0, then f of x is decreasing. For this reason, we first compute the derivative of f prime of x equal to 3x squared minus 1. And now we wonder when this function is bigger than or equal than 0. So this is a quadratic equation, and we can easily find the solution. So 3x squared minus 1 equal to 0, which means that x is equal to plus or minus 1 over square root of 3. Now we put our two values, minus 1 over square root of 3 here, and 1 over square root of 3 here. And now we want to identify the sign of this function. We can evaluate it at the point 0, at the point 1, and at the point minus 1, for example. And we evaluate it at 0. F prime evaluated at 0 is equal to minus 1, so this is going to be negative. When we evaluate it at 1, we have 3 minus 1, which is positive. And when we evaluate it at negative 1, we're going to get still 2, which is positive. And now we are going to do this little diagram that tells us when the function increases or decreases. For example, whenever we see a plus sign, we are going to draw a line that goes up. Whenever we see a minus sign, then we're going to draw a function that goes down. And afterwards, whenever we see a plus again, we go up again. And now you can immediately notice that this line here is increasing because it's going upwards. This part is decreasing because it's going downwards. And this part here is going upwards, so it's increasing. Then the same applies to our function f of x. What does it mean? It means that f of x is increasing whenever we see this line increases, which are in these two intervals, which means that f of x is increasing between minus infinity and minus 1 over square root of 3, union 1 over square root of 3 plus infinity, and is decreasing between minus 1 over square root of 3 and 1 over square root of 3. As a second exercise, we are going to do the same things as before, but now for the function f of x equal to the log of x plus 1 plus x. We follow the same scheme, so first compute f prime of x, and it's going to be equal to the derivative of the log is 1 over x, so we have 1 over x plus 1 in this case, plus the derivative of x is 1. And now we have to identify the interval where the function f prime is bigger than or equal than 0, which means that we want that 1 over x plus 1 is bigger than or equal than 0. Now what we do, we have to do the common denominator. In this case it's pretty easy because we have just one denominator, which is x plus 1. So x plus 1 plus, and then we have to divide this imaginary 1, we divide x plus 1 by this imaginary 1, which means that we get in the end x plus 1 here, bigger than or equal than 0. That can be rewritten as x plus 2 over x plus 1, bigger than or equal than 0. As before, we have to identify the 0 of the numerator and the denominator. The numerator becomes 0 when x is equal to minus 2, and the denominator instead becomes 0 when x is equal to minus 1. So I can write minus 2 here, minus 1 here. And now what do we do? Well, we can evaluate the function x plus 2 over x plus 1 in between these intervals. So we have to find some points where between these intervals, where we have an easy point here is 0 for sure. Here there is minus 3, and between minus 1 and minus 2 for sure we have minus 1.5. Great. Now let's do the evaluation. When x is equal to 0, x plus 2 over x plus 1 is equal to 2, which is a positive number, so I'm going to write plus here. When x is equal to minus 3, I'm going to have minus 1 in the denominator and minus 2 in the denominator, which means I have minus 1 divided by minus 2, which is plus 1/2, because minus times minus is equal to plus. So plus sign here. And at minus 1.5, what do I have? Well, minus 1.5 plus 2 over minus 1.5 plus 1. This is equal to 0.5 over minus 0.5, which is equal to minus 1, which is negative. Therefore, we have a negative 1 here, which is a negative number, so we can just write the negative sign. As before, we're going to do our little drawing, and we have a plus sign between minus infinity and minus 2. Then the function is going to decrease between minus 2 and minus 1. And afterwards it's going to increase again because we have a plus sign. So now we see our little lines here, and we see that it increases between minus infinity and minus 2, and after minus 1 increases again. Therefore, we can conclude that f of x is increasing between minus infinity minus 2 union minus 1 plus infinity, and f of x is decreasing between minus 2 and minus 1. Last exercise for today. So we're going to try to understand when the function f of x equal to e to the minus x squared plus x is increasing or decreasing. So we have to compute this derivative. It's a bit more complicated than usual, but it's just a chain rule. So we compute f prime of x equal to, so e to the x, the derivative is e to the x, so we're going to keep e to the minus x squared plus x, and then we have to differentiate the exponent, which is minus 2x plus 1. And now we have to understand when this f prime of x is bigger than or equal than 0. Okay, great. So how do we do it? Well, f prime is, we just computed it, and we said it is equal to e to the minus x squared plus x times minus 2x plus 1. Okay? And I want to understand when this is bigger than or equal than 0. Now, this exponential, e to the minus x squared plus 1, is going to always be bigger than or equal than 0 for the property of the exponential. Indeed, you remember that whenever we plot the exponential function, e to the x, we see something like this, which is never negative. So we can immediately conclude that e to the minus x squared plus x is always positive. Okay, never zero. So we can simplify by the number on both sides without changing the sign of inequality. So this is going to be perfect. So we have just to study wherever minus 2x plus 1 is bigger or equal than 0, which means that x has to be less than equal than 1 over 2. That's easy. We have just, this is our interval. Let's do our little scheme again. So we have here 1 over 2. And before 1 over 2, we know that the function is positive. So we have a plus sign here and a negative sign there, which means that we are going to have a function increasing and then decreasing afterwards, which means that f of x is increasing between minus infinity and 1/2, and f of x is decreasing between 1/2 and plus infinity. That's all I have for you for today. See you next time.